Hey, welcome back everybody. In this video, we're going to be looking at something a little bit different, but I wanted to update you on my last video where we were talking about the potential for Bitcoin to be in a 5-wave pattern to the upside, and I said specifically that we would need to hold this level here in order to have confidence that we were making one more wave back up. And as you can see, we didn't hold that price level there. We crashed actually way below it, more than $10,000 below it, depending on what exchange you're on. And we took out this height of wave one here that we were hoping to hold as support. So I don't have a lot of confidence in Bitcoin right now. I don't know. Obviously, it can continue to go much higher, but this is not a great technical setup. So until we learn a little bit more over the coming weeks about what happens with the greater stock market, which also crashed along with Bitcoin and in the crypto markets, we don't really have a lot to go off of right now. Instead, I thought today I would talk about some of the very basics of cryptocurrency and blockchain technology so that you can have some sort of understanding about how it works. Bitcoin was the first cryptocurrency. It's also the largest cryptocurrency by market cap. It was created in 2008 in the midst of the great financial crisis by Satoshi Nakamoto. Now, this is a pseudonym for someone, a man or a woman or a group of people, an organization. We don't know who created Bitcoin, but they published a paper and set up the network to start running and originally mined some of the first Bitcoin. Since then, we've not heard from this person and no one has ever figured out who it was. A cryptocurrency is simply a digital token run on a blockchain. A blockchain is a digital ledger of transactions that is duplicated and distributed across a network of computers. In other words, a blockchain is a digital database. It stores data on an ever-expanding ledger in discrete blocks, which can be added to the very end of the ledger, but existing blocks cannot be changed once they're created. Whenever a new block is added to the blockchain, all of the computers that are running the network update their version of the blockchain to reflect this newly added block. Blockchain technology itself has been around longer than Bitcoin, but Bitcoin made a fundamental change to the blockchain which inevitably gave it its monetary value. Bitcoin is decentralized, meaning there's no central control over it. No government or institution or individual has a majority control over Bitcoin or the ledger on the Bitcoin network. Everything is written into the code from the very beginning, and the code runs itself. I'll leave a link to this video here about the blockchain if you want to watch something else. I found it very helpful. So, the order of events. A new transaction is entered. The transaction, as well as many others, are then transmitted to a network of peer-to-peer computers scattered across the world. These are called nodes. They are what run the Bitcoin network. The network of computers then solves equations to confirm the validity of the transactions. Once confirmed, the transactions are clustered together into a block. This block is then added to the chain of previously existing blocks, and once several blocks are added to validate it, the transaction is considered complete and cannot be altered. Bitcoin uses cryptography to securely track transactions on the Bitcoin ledger. It specifically uses an algorithm called SHA-256, or Secure Hash Algorithm, 256-bit. 256 bits is enough to store 64 alphanumeric characters. So, SHA-256 is an algorithm that creates a unique output, also known as a hash, for any given input. A hash is simply a mathematical computer process that converts information into a sequence of letters and numbers. Hashes, importantly, are a one-way function. They make information unreadable, so the original data can never be guessed if you have the output hash. For example, if I typed into a hash function the phrase "I like Bitcoin," the output will give me 64 characters consisting of letters and numbers. Anytime I type in "I like Bitcoin," I will receive the same exact hash output. However, if I make any changes to that, for example, we capitalize the B in Bitcoin, the hash will be completely different. For any given input, there will be one and only one unique output. So let's look at an individual block. Now, this is simplified to make it easy to understand, but there's a few things that go into a block on a blockchain. First, there's a place for a random number. This will be important. Next, there's a place for you to store data or transactions. The final input is the unique hash output from the previous block that this block follows. So if this block is block 10, block 9 would have produced an output that starts with 000, capital B, Q, 3, capital H, etc. Then all of the inputs, the random number, the transactions, and the previous hash are sent through the SHA-256 algorithm, and a unique hash for this block is created. To add a block to the blockchain, the output hash must begin with a certain number of zeros. This is a rule written into the code. Since the output is randomly determined, it can be extremely difficult to find an output that has, say, 3 zeros as the first characters. In order to do this, we have to mine for crypto. This is how that works. Here we have in blue previously validated blocks. Block 3 is now trying to be added to the blockchain. We have a place for the random number input. Transactions taken from the Bitcoin network. These are people who posted their transactions and are waiting for them to be approved and added to the ledger. It automatically takes the hash from block 2, and now the miner needs to find a way to get the output hash to begin with 3 zeros so that this block can be added to the blockchain. In order to do this, the miner will run a simple code script on his computer that will test various random numbers as an input. Remember, any change to the input will create a completely different hash. So, with the transactions set in place, the computer starts running through possible random numbers. Each one creates a unique hash output. The computer will continue to do this until it finds one with the set number of zeros at the beginning. Once it finds that, the block will be confirmed. This miner will send this block out to the network, where all of the other miners will receive it, verify that the hash is correct and the transactions are legitimate, and then they will accept this block to their version of the blockchain. If somebody wants to make a change at any point in the blockchain, say in block 1, they want to alter transaction 3, that alteration will change the unique hash output, which will make the block invalid because it won't begin with 3 zeros. Even if it did begin with 3 zeros, it would then change the rest of the hash, which would cause this hash output to be different. So, changing one item anywhere in the block will change and invalidate every block that comes after it. Even if you successfully remine block 1, the hash will still be different and will result in block 2 and all the following blocks being invalidated. In this way, you cannot successfully change the blockchain. Imagine then you tried to remine block 2, remine block 3. Because it takes time and computing power in order to mine for these blocks, and other miners are consistently adding blocks to the end, by the time you got a correct hash output for block 2 and block 3, someone else would have already validated block 4 or 5 or 6. And so it becomes ever more difficult to make changes to the blockchain the further back in the blockchain you go. This is also the reason why for Bitcoin and for many other cryptos, it takes several blocks being added before a transaction can be considered complete. For Bitcoin, I believe it takes 3 blocks being added. Since a block is added to the Bitcoin ledger every 10 minutes, that means that your transaction will take about 30 minutes to be verified. Now, the last thing we'll look at is what happens inside the block. We want to understand how transactions actually work on the Bitcoin network. And again, this is an oversimplification, but we're going to assume 2 people want to send some Bitcoin. Mike wants to buy a Tesla for 1 Bitcoin. There was a time earlier this year when you could buy a Tesla with Bitcoin, and 1 Tesla at that time would have probably cost around 1 Bitcoin. Mike previously received Bitcoin in blocks 21 and 38, and he has a Bitcoin wallet address. So he is the sender, and this is his wallet address. It starts with 0x159. It would be much longer than this. He's sending 1 Bitcoin, and he is sending it to another Bitcoin wallet. In order to verify that Mike actually has 1 Bitcoin available to send, he puts in receipts. Essentially, in each transaction, he needs to reference the previous blocks where he received Bitcoin. So on block 21, he received 0.6 Bitcoin. On block 38, he received 0.4 Bitcoin. He adds both of those there, and that allows the miner to easily go back, check block 21 and block 38, confirm that this amount of Bitcoin was sent to this wallet address, and then that Bitcoin can be sent to the recipient. Likewise, Lisa has a wallet address. She wants to send 0.7 Bitcoin to a different wallet. This could be someone else's wallet, or this could be another wallet address that she owns. Perhaps she bought 1 Bitcoin on an exchange during block 8. Now, she wants to send some to a cold storage wallet. This is a type of device where it holds your Bitcoin key offline so that it cannot be manipulated or stolen through a hack. Now, she wants to keep some of her 1 Bitcoin on the exchange and only send 0.7 Bitcoin to this other wallet. In order to do this, because she bought 1 Bitcoin in block 8, she not only has to send a transaction to the new wallet address, she also has to send, you can think of this as her change, back to herself. So you'll see this is her initial wallet, and she's sending 0.7 Bitcoin to a new wallet address and then sending 0.3 Bitcoin back to herself. And that clears out this whole Bitcoin here. Now, this is her new receipt. In addition to the 2 senders, Miner Joe is rewarded for running the network and correctly adding the block to the blockchain. This is how new Bitcoin are created. Every time a block is added, there is a mining reward. In this case, it's 1 Bitcoin, and the miner signs this block with his own wallet key as a signature. Hopefully this helps explain how Bitcoin are held. They're simply held within the ledger itself, how Bitcoin is sent from one wallet to another, and how Bitcoin is created. Thanks for watching. If you enjoyed this video, please like it and consider sharing it with other people who would find it informative. Otherwise, I'll see you in the next video. Have a good one.